Hey everyone, and welcome. Our entire digital world, from the biggest servers to the smartphone in your pocket, it's all built on layers and layers of code. But what if I told you the security of that entire world could be cracked open by a single misplaced word? Well, today we're going to dig into a really fascinating debate about one obscure keyword in the C programming language and how it perfectly captures this constant battle between writing perfect code and just making things practically safe.
And I know that sounds super dramatic, right? But it's absolutely true. How can one tiny little keyword in a programming language that's been around for over 50 years cause such a huge debate among some of the smartest developers on the planet? So let's break it down.
All right, here's our game plan. First up, we're going to expose a hidden danger that's been lurking in the C language for ages. Then we'll check out two really clever but totally competing solutions that were proposed. After that, we dive headfirst into the heated, horrible hack debate that followed, and finally, we'll reveal the surprisingly practical path forward that was chosen in the end.
Okay, so first things first, let's set the stage. The C programming language is an absolute workhorse. It's the foundation for so much of our technology. Maybe most importantly, the Linux kernel, which powers, most of the internet servers and all those Android phones. But for all of its power, C has this subtle but really dangerous weak spot. The issue is called the array parameter problem. Probably the easiest way to think about it is like this. Imagine you're sending a package, but you forget to write down how many items are actually inside. The person receiving it might be expecting 10 things, but you only sent 5. Or worse, you sent them the wrong package entirely. Now, in programming, that kind of mix-up doesn't just cause a little confusion. It can lead to a system crash, or even worse, a massive security breach.
And look, this is not just some textbook theory. This slide shows a real, high-stakes example right from the guts of the Linux kernel's cryptography code. This function here, it handles a secret key and a special one-time code called a nonce. If a developer accidentally swaps them or passes in one that's the wrong size, the compiler, it just looks the other way. It has no idea. And in the world of encryption, a tiny mistake like that can make the entire system completely insecure.
Okay, so how do you even begin to fix a problem like this? Well, the developer community came up with two very different and honestly very clever tricks to basically force the compiler to check the size of the data it's being handed.
And this slide lays out the two competing ideas perfectly. So on the left, we've got what we'll call the pointer trick. It is super precise. It forces an exact size match. The catch? Every single programmer has to remember to stick this little ampersand symbol in their code when they use it. And trust me, that's really easy to forget. Then on the right, you have the obscure keyword solution. It uses this little-known feature of the C language with the word static. This checks if the data is at least the right size. And the best part? It requires 0 changes from the developer using the function. It just works.
So the obscure keyword seems like a total slam dunk, right? It's safer for the system and it's easier for the developer. But you know how it is in high-stakes software engineering. Nothing is ever that easy. And this is where the real debate kicks off.
And this is where things get really interesting. Because even Linus Torvalds, the famously blunt creator of Linux, he weighed in. Now, he actually liked what the feature did, but he called its design a horrible hack. His argument was that the language designers were just lazy. They reused an existing keyword, static, in a way that makes no logical sense, just so they wouldn't have to break any old code.
So that really begs the question, right? If the feature works and the leader of the entire project is basically giving it a thumbs up, what's the big deal? Well, as always, the devil's in the details, and in this case, it was in the fine print of the official C language rulebook.
This table really breaks down the whole conflict. The arguments for it are all about practicality. It's easy, it catches dangerous errors, and it's already being used in a few places. But the arguments against it, they raise some serious red flags. Critics pointed out that the official C standard just calls this thing a hint for the compiler, not a mandatory safety rule. Even worse, they were worried it could be a UB bomb. UB stands for undefined behavior, which is basically a programmer's worst nightmare. It means your code isn't guaranteed to do anything predictable. It could crash, or, in a wild twist of irony, create a brand new security hole.
So you've got these two camps, right? Strong arguments on both sides of this really technical divide. What did the Linux kernel developers decide to do? Did they go with the clunky but super precise method, or the easy one that was potentially a ticking time bomb?
Well, it turns out they didn't pick A or B. They went for a third option, a really clever compromise. They decided to embrace the benefits of the horrible hack, but hide its ugly and confusing syntax away from everyday developers. They found a way to get the safety without all the confusion.
And their solution was something called a macro. Now, for anyone who's not deep in the coding world, a macro is just a shortcut. It lets a programmer give a simple, clean name to a much longer, more complicated chunk of code. You can think of it like creating your own custom command or alias.
And this is the really cool part. The kernel developers created a new macro called @least. So now programmers can just use this simple, descriptive tag in their code. It makes the intention crystal clear. And behind the scenes, that macro automatically inserts the horrible hack with the static keyword, giving them the safety check they needed all along. It's really the best of both worlds.
You know, this whole story is just a perfect little snapshot of how real-world software engineering actually gets done. It shows that progress isn't always neat and tidy. A lot of the time, it's slow and messy. It's this constant balancing act between the dream of a perfect design and the day-to-day reality of practical safety. And it proves that even a 50-year-old language like C is still evolving, pushed forward by developers who are focused on solving real problems, even if the solution isn't exactly perfect.
And all this leaves us with one last big question to chew on. When so much of our critical digital world is built on code that's decades old, is this kind of pragmatic, good enough safety the best we can hope for? Or is it a dangerous compromise that's actually holding us back from achieving true, perfect security? Something to think about. Thanks for watching.